This is where we left off on Friday. We were graphing the tangent function. And if you remember, we figured out where the tangent function had vertical asymptotes. You remember that? What we figured was the tangent function had vertical asymptotes anytime the cosine was 0. Because remember, tangent is sine over cosine. And we said anytime the denominator is 0, that function's undefined. So tangent is undefined when cosine is equal to 0. And what we said was, well, cosine is equal to 0 at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and then going the other way, negative pi over 2, negative 3 pi over 2, and so on. Right? We good there? But we said, well, we can't write all those down because dot, dot, dot's not acceptable. So what we wrote was vertical asymptotes happen, and you can put x or theta. I don't care. Pi over 2 plus pi k, where k is an integer. And if you remember, and I know it's been 4 days, this little formula right here, bless you, allowed us to generate every one of those vertical asymptotes. Do we need to go through that again, or are you okay there? All right. So we said the domain then, and I don't remember, did we talk domain? Was everything but those vertical asymptotes. So we said the domain was all x or theta. Again, it doesn't matter which variable you use, just be consistent. So if I'm going to use x down there, I'll use x up here, such that x is not equal to pi over 2 plus pi k. Now, you do need to write where k is an integer. But you just need to write it once. You don't have to write it on every step. Just one time is sufficient. Did we talk about the range? Okay. Range. As I'm graphing in this one little section, this one little interval, do I ever have to lift my pencil? Are there any y values that do not get included? Every y value gets included. So what's the range? All real numbers, right? Okay, so what else do we need? Okay, is this a continuous function? If I'm in a graph tangent, do I ever have to lift my pencil? I sure do. I got to lift my pencil at every vertical asymptote. This is a discontinuous function. Now, there is a phrase that you're going to hear, and I'll be honest with you, it drives me batty. I get it, but what you will hear some college professors say in some textbooks is they will say it is continuous on its domain. Well, if the domain leaves out all those vertical asymptotes, it's continuous everywhere else, isn't it? That function is discontinuous because it's got vertical asymptotes. But you will hear some authors say the function is continuous on its domain. It's weird, isn't it? That's always bothered me, but I don't know. As long as you have already stated what the domain is, you can say it is continuous on its domain. So on each one of these little subintervals, I don't have to lift my pencil. But to get from one subinterval to the next, I have to lift my pencil. But that's okay, because where I have to lift my pencil is not in the domain anyway. That's just weird. Symmetry. Does that sucker have any symmetry? What kind? With respect to the origin. This thing has symmetry with respect to the origin, so it's called a what kind of function? Odd. Yep, it's called an odd function. So this thing has origin symmetry. It is an odd function. Remember, which means f of the opposite of x is the opposite of f of x. Go to where it says, go to D, because I skipped D, increasing or decreasing. Now, when I say subinterval, what I'm meaning, and I've got to do this so that hopefully Dixit and Tanner watch this. Are you watching it? Okay. On a subinterval, and I'm talking about between asymptotes, is that function always increasing, always decreasing, or doing a combination of the two? It's always increasing. So what you'll say is the function is increasing on each subinterval in its domain. The function is increasing on each subinterval in its domain. Everybody got that? Go to F. Is this function bounded? Which means, is there an upper limit and a lower limit? No. This function is what we call unbounded. Unbounded. What are the extrema? What is the highest point and the lowest point? There aren't any, because if it's unbounded, there aren't any extrema. That's exactly right. Right, and that's why I said if the function's unbounded, there aren't any extrema. Yeah, it's just some different terms I want you to make sure you understand. That's all that is. H. Are there any horizontal asymptotes? Nope. We've already done the I, right? The vertical asymptotes. Leave out the end behavior. That's not an issue. Now let's go to your calculator. And I want you to look at question number 7. A times tangent x. What does A typically stand for or affect? The amplitude. So, how in heaven's name are we going to have an amplitude on that graph? Go down to y2. Make sure you have tangent x in y1. Go down to y2 and put 3 tangent x. Now you better check your window. I'm going negative 2 pi to 2 pi. Is yours negative 2 pi to 2 pi? By pi over 2? Graph. Now John already knew what happened. What happened? Do you remember when you did move the monster and you had something like 3x squared? What did the 3 do? It was a vertical stretch. Since tangent doesn't have amplitude, we just say that tangent was vertically stretched by a factor of 3. So the y values all got multiplied by 3. So what are you going to say on number 2? How does A affect the graph? You're going to say A is a vertical stretch or compression. I hope I said that on here. So how does A affect the graph on your number 2 in your notes? A is a vertical stretch or compression. What if A is negative? It's a reflection over the x-axis. So what if you go back here, take out that 3, and just make it a negative tangent x? This is where if you've got a color graph, where it's going to make you can make some pretty pictures. Now let's go down to your number 4. What about tangent of BX? Oh, I didn't say something. Let's go back. We got to go back and talk about tangent. I haven't talked about something here. What's the period of tangent? How long does it take to make one of those subintervals? Go back. It takes pi to make one of those subintervals, doesn't it? So if we go from pi over 2 to 3 pi over 2, and then we copied and pasted that, it would keep repeating over and over. Ladies and gentlemen, you need to know that the period of tangent is pi. It is not 2 pi, it is pi. Oops, that's not what I wanted to do. I want to do that. So let's look at your number 4. Now this is going to look this is going to look ugly. What if we graph tangent of 2x? Now before you hit graph, what's the new period going to be? Your new period is the old period divided by b. What's the period of tangent? Pi divided by b. So your new period is pi over 2. So let's see. I know, it's very confusing. So let's see if we can process it like this. I'm turning off the first one. Is that a little better for your eyes? We're able to fit 2 periods where we used to fit 1. So I want you to look on number 4. How does B affect the graph? What is the original period of tangent? Original period is pi. Your new period is pi over b. The original period is pi, and your new period is pi over b. This is your number 5. Now, you can do this on your graph paper, but you don't have to. We can just do it over on the side of number 5. We're just going to make a little sketch. So, what is the only position, A, B, C, D, where you actually have a number? B. What is B? Now, B is not 2. B is a half, because what number is multiplied by x? A half. So B is a half. B affects the period. So your new period is the old period, which was pi, divided by B, which is, you with me? Your period is 2 pi. Now let's talk about your tick marks. On sine and cosine, you have 4 important places, right? So like on cosine, it starts at a max, and you go 0, min, 0, max. Let's talk about tangent. If I start at a vertical asymptote, I do a this, and then I do another vertical asymptote, and I do a this, and I do another vertical asymptote. If I start at a vertical asymptote, I only have 2 important points. Where's the 0 and where's the next vertical asymptote? That's it. So we only have 2 important points on tangent. So what you're going to do then is your tick marks are going to be the period, the new period, divided into 2 equal parts. So your tick marks, your spacing on tangent is the new period divided into 2 equal parts. So let's make you just a quick sketch, okay? It does not help you to tick mark off the vertical axis because there's not a maximum or a minimum, okay? Your tick marks, let's make them pi. So pi, 2 pi, 3 pi, negative pi, negative 2 pi, negative 3 pi. I would probably suggest, well, if you were doing this on graph paper, I'd probably suggest you go every other mark to make pi. Do you remember on sine and cosine, our question was where does it start? Does it start at a maximum or a minimum or the origin? Or the origin? For tangent, the question is it starts at 0 because tangent goes through the origin. You with me? So here's what I know. I know this thing goes through the origin because there was not a horizontal shift. Okay, that's one of my important points. What's the next important point after a 0 on tangent? A vertical asymptote. And how far apart are the important things? Pi. So what I've got a vertical asymptote there. And then I got a 0. And then I got a vertical asymptote. Remember, your important things are pi apart. If I go left, here's my 0. I have a vertical asymptote. Then I have a 0. And then I have another vertical asymptote. Does that sort of make sense? Now remember, just for easiness, tangent always goes up to the right. Now, I need you to understand something about why that is. This section right here, from 0 to pi over 2, is what quadrant? It's the first quadrant, isn't it? 0 to pi over 2 is quadrant 1. In quadrant 1, is tangent positive or negative? Positive, so that's why in between 0 and pi over 2, this thing has to be above the x-axis because the tangent values are positive. So we know that this thing goes, oops, don't touch the vertical asymptotes. Hug them, but don't touch them. Look at number 6. We're not going to get this deep into tangent. I just want you to know, what would the C do? C would be a phase shift, but if you've got a B, what do you have to do? Factor it out, just like on sine and cosine. So C affects a phase shift. What does D do? D would give you a vertical shift. Again, the most important ones to know about graphing are sine and cosine. That's why I've spent the bulk of the time there. But I just need you to have a basic understanding of the other 4 trig functions, okay? Now, I'll tell you what we're going to do. We're going to graph the other 3. But we're going to not get real deep into the notes. We're just going to do some basic stuff about the other 3. So if you'll go down to number 10, cotangent. What in the world is cotangent? An opposite? Opposite reciprocal inverse, right? It's the reciprocal. The only way you can graph cotangent on your calculator is to do 1 over tangent. There is not a cotangent key. Go to your calculator. And we're going to graph, just clear these out. We're going to graph cotangent. There are some things just the same as tangent, and then there are a few things that are different. Can you look at that graph and look at the graph of tangent? What's one thing that's different? This one doesn't go through 0, 0. Okay. What else, Adam? Good. Okay, so it doesn't go through 0, 0. What do you mean it goes the other way? Perfect. So instead of sort of looking like an x cubed, it sort of looks like a negative x cubed. What kind of symmetry does it have? It's still got origin symmetry, so that's the same. So your differences are this thing goes down to the right instead of up to the right, and it doesn't go through the origin. What does it go through? Oh, right. Where tangent had a vertical asymptote, cotangent has a 0. Wonder why that is. Wonder why that is. Because cotangent is that. Aha. Cotangent is undefined when sine is 0. So where are the vertical asymptotes on cotangent? Can you come up with some angles that have a sine of 0? What are some angles that have a sine of 0? 0. What else? Pi. 2 pi. 3 pi. ... Negative pi. Negative 2 pi. ... But remember, we're not allowed to write down ... So you say, well, all right, self, how do I write this? On tangent, no. Yeah. On tangent, what you had to do was you had to come up with the first angle that was not negative and start there. What's the first angle in this list that's not negative? 0. So you're going to write down 0 plus, but do you even have to write 0 plus? How far apart are those vertical asymptotes? Pi k, where k is an integer. That's where your vertical asymptotes are. Where are your zeros? A fraction's equal to 0 when? Good. When the numerator is 0. When is this numerator equal to 0? When cosine is 0, which happens at pi over 2 plus pi, right, so pi over 2 plus pi k. So you have zeros at pi over 2 plus pi k. Ladies and gentlemen, those are flipped for tangent. And that should make sense because this is flipped. That's all that's important right there. So we're not going to go through all the rest of it. Now, go to your number 11. The secant function. I love these last two. By the way, don't do to yourself what I did once a long time ago. I wrote secant x and I accidentally left out the c. And I heard somebody snicker and I looked and I went, oh, holy crap, look what I just did. So every time now that I write secant x, I am so careful. yeah, exactly. You do not have a secant x button on your calculator to graph. How do you graph secant x? Now, before you graph this, before you graph this, I want you to think about what you might see. Is there anything interesting that you might see? Say again? I didn't hear what you said, Hudson. Oh, okay. I didn't hear what you said, so all right. When is secant x equal to 0? When's a fraction equal 0? When the numerator is 0. When's the numerator 0? Never. This thing is never going to cross the x-axis. Never. What? Does it have vertical asymptotes? When does it have vertical asymptotes? When cosine is 0. This could be an interesting thing. It never crosses the x-axis, but it's got vertical asymptotes. Let's get in there and graph it. Isn't that cool? Now, so how do you know where where the highest point is there and where the lowest point is there? Well, I don't know how you know that. Table. Let me show you something. Graph this. Graph this.
Whoa.
Where cosine has a maximum, secant has a minimum. What? I know. Where cosine has a minimum, secant has a maximum. Every place that cosine is equal to 0, secant is undefined, so there's a vertical asymptote. Oh my goodness. Is that not cool? I think that's so cool. So, you keep the picture on your screen. I'm going to ask you some questions. Where are the vertical asymptotes? Oh, I don't need that. Yeah. All x such that x is not equal to... Where is cosine 0? Where is cosine equal to 0? Pi over 2 plus how often? Yep. And we're going to look at domain and range. So you ought to know that in the domain... Oh, snap. I should put equals there, shouldn't I? That's where the vertical asymptotes are. I was getting domain and range, or domain and vertical asymptotes put together. The domain leaves out the vertical asymptotes. What's the range? Look at the blue. What about -1 and 1? Is -1 a value that secant can get? Yep. Is 1 a value that secant can get? Secant can be 1, right? The y value. So everything except what's between -1 and 1, right? So you think, well, how do I write that? Here's how I want you to write it. Your range write that down, then we'll talk about it, make sure you understand what it says. everything from negative infinity up to -1, but it includes -1. And then we leave everything out until we get back to 1. And then everything above that. You okay? All right. Now, go down to, let me see here. Oh, period. What's the period? That's the last thing. We need to talk about period. How much would you, what would you have to copy and paste on this blue? You're saying like between here and here? I could do it that way, yes. Or I could do it between like here. Yep. What's the period of cosine? 2 pi. So period of cosine is between here and here, correct? Well, a maximum of cosine gives a minimum on secant, like this. So to get back there, it's still 2 pi. Right. The period is still 2 pi. The only ones that have a period that's not 2 pi are tangent and cotangent. That's it. Sorry? You still use 2 pi. Yeah, 2 pi. Yeah, everything else is the same. Yep. No, and that's a good question. That's a good question. I want you to look at these pieces right here, these U-looking things. Are they parabolas? Are they parabolas? Yeah, I hear you. They look like parabolas, don't they? Michael's x squared. What's the domain of x squared? All real numbers. What's the domain? What's the domain of secant? Is it all real numbers? No, not parabolas. These things have what we call, are you ready? Asymptotic behavior, which means in between those asymptotes, this thing hugs the asymptotes, but it never touches them or goes past them. X squared does not have any vertical asymptotes. It keeps going on and on. So this is not a parabola in the same way a tangent piece is not an x cubed. It's just kind of like an x cubed. Cosecant. How do I graph cosecant? 1 over sine. Oops. Now, before you graph. Before you graph. And I think we're on number 12, right? Asymptotes. Where the asymptotes will happen when, and don't tell me numbers. Look at that equation. Perfect. When sine is 0. When is sine 0? What are some angles that have a sine of 0? 2 pi, pi, 0. How is this one similar to secant? It's got the same shape. Say again? Yes, it's just a horizontal shift from cosecant, from secant, yes. It has the same shapes. It has the same domain. No, it doesn't either. It has the same range. Let's talk domain. Is the domain the same? We didn't talk about symmetry on secant. Is the domain this? What's the domain of this thing? Watch this. If you can graph sine, you can graph cosecant. Cosecant has zeros everywhere that sine is 0, right? So y equals cosecant x. Has vertical asymptotes. Zero pi, 2 pi, negative pi, negative 2 pi, pi k, when x is equal to pi k. So your domain is all x such that x is not equal to pi k. Talk about your range. My blue. What's your range? Same as secant, right? Same as secant. So negative infinity to negative 1, with negative 1 included, and 1 to infinity. Again, I forgot to mention symmetry. What kind of symmetry does cosecant have? Origin or y-axis? It's going to have the same symmetry as sine does, which is origin. So cosecant has origin symmetry. Let's go back because that's the one I forgot to do. Yep. This is secant. Secant has y-axis symmetry. Now listen, if you want to know what kind of symmetry secant has, just remember secant is 1 over cosine. Cosine has y-axis symmetry, so secant does too. And that, ladies and gentlemen, is what you need to know about the graphs of the 6 trig functions. Okay? Period is still 2 pi. Period is still 2 pi. Sine, cosine, secant, cosecant all have periods of 2 pi. Tangent and cotangent have periods of pi. Right. The A, B, C, and D still do A, B, C, and D, except on A with a tangent and cotangent. What does A on a tangent or cotangent show you? Because you don't have an amplitude, right? You just say a vertical stretch. Okay. Now, if you notice there's a really long assignment there, you are not doing that really long assignment, okay? I'm going to have you graph one of each. A tangent, a cotangent, a secant, and a cosecant, okay? One of each, and they're simple ones. We are on page 365 is where this thing starts. Page 365 to 367. 5 through 11 odd. And that is the piece that is one tangent graph, one secant graph, one cotangent graph, and one cosecant. Yeah, it's one of each. You'll just graph and write down the important things. That's all you do on those 4. Now, the next piece is 29 through 39 odd. And those are calculator problems. So let's look at 29. Does everybody have access to a book where you can see problem number 29? Oh, hang on. 29 through 33 are no calculator, and then 35 through 39 are calculator. So we'll look at one of each of those. Look at 29. It says secant of x equal 2, but look at the restriction. It says you are in quadrant what? your 0 to pi over 2. Now, you're in quadrant 1. And it says you should be able to do that without a calculator. I don't worry about secant. What's its reciprocal? Cosine. So if the secant of x is 2, what's the cosine of x? What angle in quadrant 1 has a cosine of a half? Is it pi over 6 or pi over 3? Pi over 3. Yeah. So you'll just say x equal pi over 3. No, that's not very hard. No. Then go down to number 35. Well, shoot, I'm not going to do 35 with you because you're going to do that one yourself. Let's do 36 together. Yeah, because you're doing odd. So let's do 36 together here. Secant x equal 2.4. What quadrant are we in? It says 0 less than or equal to x less than or equal to pi over 2. Quadrant 1. Now, go back to your calculator. We got a couple ways we could do this one. We know the secant of x is, what did it say, 2.4? So I could graph secant, right? 1 over cosine. And what do I want that to equal? There's secant, and there's 2.4. Find the intersection. Now, we're only looking for one of those intersection points, because what quadrant are we going to be in? So, which of those intersection points are we looking for? Yeah, just this one right here. Why just that one? My tick marks here are pi over 2, right? And what we're looking for, the problem said the answer was between 0 and pi over 2. So I need the intersection point that is between here and here. So it has to be this one. You with me? So that's how you do 29 through 39 odd. And then 3 little problems, little application kind of, sort of. Well, actually, just 2 application, 45, 46, 47. The application type problems are 45 and 46. This should not take you very long. On Thursday, you're going to have a short quiz over the graphs of sine, cosine, tangent, cotangent, secant, cosecant. I won't have a bunch of graphs on there, but I will have probably 2 is what I'm looking at, and they'll be sine and cosine graphs. Okay. But I'll have maybe something like, on those problems that you did for today, it gave you the equation, and I might say, what's the period of that function? Or I might say, what is the horizontal shift or the phase shift, or stuff like that. And probably 1 application type problem, but it probably won't be a tied problem because those take a while to do.